Okay, so hello everyone, and I think you'll be coming on in a second. Okay, hello everyone. So today we're going to be doing another code along. This time we'll be doing a slightly different thing. We're going to be doing a Caesar cipher. Okay, and it's going to be really cool. So yes. So now let's just get started here. So everything seems to be working good. So first of all, as you can see, what I've done is I've gone ahead and created a new folder for my thing. So I created a new project, okay? Then with that link over here in the description, I went and I downloaded that file, and then I saved it into the root folder of the project. So you go to your workspace, you click on the name of that folder, double click on it, it'll open that, and you'll see folders like bin, src, bin and src, and then you paste it right there. You don't paste it in src or bin. So that's how you get the dictionary file set up. So now our thing is gonna have a few basic features. Okay, it's gonna first be able to encode text into Caesar cipher, decode text from Caesar cipher, which is pretty much the same as encoding. So, and then at the end, I'm gonna show you a way to do things, also known as a cool feature that I'm gonna add later. I'm gonna show you what to do later. Well done. Watch time equals optimized. Okay, anyway, so you can, this is basically a documentary of how I made my repository. If you want to just get my repository, you can go to the link in the description, and it'll show you how to make a Caesar cipher and all those things. Yeah, good things. So yeah, now let's get started. So first we're gonna make a few basic variables. The first one is going to be a private static final string letters, which is going to contain all the letters in the English alphabet. Okay, so this should basically go A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U, V, W, X, Y, Z. So just check that once to make sure there's nothing wrong with that. It seems all good to me. So let's go on to the next one. So that's all we need for now. Just make sure the dictionary file is there and you're all set. So now we have it in package Caesar decoder and everything seems to be good. So let's make our encode function first, shall we? So, well, we have to. Okay, so it's a private static string because it's going to return a type of string, but it's going to basically return a string that is the encoded text. So private static string encode, just a sec here. Okay, private static string encode, and it's going to take a few arguments, and we need a return statement, of course. So just a second here. Okay, cool. So now since that is all set up, first of all we need an input string and then the shift. So the input string is going to be string text, then int shift, which is the shift. If you haven't read on the Caesar cipher, I'll just add a link to the description real quick. Okay, in the meanwhile, let's get this working because some reason my internet is acting up. Okay. Okay, cool. So I'll just add it here. Just a second. Okay, I guess that's gonna save or something. Okay, cool. So now that I've set all of that up, we're pretty much ready to begin. So now the encode function is gonna basically first we want to make the text into lowercase just to make sure we don't have problems later on. So text dot to lowercase. Wait, what am I doing? Okay. My IDE is lagging, which is not good. Okay, so first we need to set text is equal to text dot to lowercase. Okay, cool. So that seems to be working. Now the next one we're gonna do is we're gonna have a string builder, okay, because it's more efficient than just appending to a string. So string builder, cipher text builder, and we'll set it equal to a new string builder because we don't have any existing string builder objects. Okay, so now we're gonna split this text into a char array in our for each loop. So for each string char c in plain text to char array, we're gonna do it. So for each letter, we're gonna append a particular, okay, not plain text, what am I doing? Text. Okay. For each letter in, okay, I had to stop there for a second because the stream output was bad. So now for each char c in text.toChar array, we're gonna perform a particular operation on it. So okay, so first we're gonna check if, wait, what? Okay, so we're gonna check if letter contains the characters toString. Since we can't just feed it a character directly, we're gonna have to feed it the toString of the character. So character if letters contains. So this is gonna check if it's an English letter. Otherwise, it's gonna call another part of the function. Letter dot contains character dot toString c. Perfect. Now we'll just do it, and we're all good. So now if it's not a symbol and it's one of these letters in here, right, then we are going to add the ciphertext. Otherwise, we're just gonna go ahead with the symbol itself. Okay, so now what we're gonna do is we're going to take the index of this char from this. So for example, if we did letters dot index of c, where c was equal to a, we would get 0 because a is element 0. If it was for d, then it would be element 3. If it was for e, it would be element 4, and so on and so forth. So that's basically what we do with our index of function. Then we're going to add it to the shift, which is here. So for example, if a and the shift, if the character we have is a, then the index would be 0. Then if we add 1 and then take the char from that, it would be b. So if we do char add for that plus shift key, where shift is equal to 1 and c is equal to a, it would return b. If the shift was equal to 2, it would return c, and so on and so forth. So what we're going to do here is we're basically gonna say, okay, let's plan out the equation first. So it'll be letters dot char at, right? Then we're gonna get the index which we want the char at. So first we're gonna put another bracket, and then we're gonna shift key, which here in this case is just shift. So do that. Shift plus letters dot index of C, right? And then we mod this by 26. So basically what it's going to do is, since like for example if our value was V, okay, and the shift was, let's see, 1 2 3 4, okay, the shift was 5, okay, then what would happen is it would give 27, well 26, and since there's no index 26 in this, that's definitely not good. So basically we want to subtract 26 from that, so it'll become to turn into A, which is what it's supposed to do. So that's why we're modding it, we're doing the modulus by 26, and we just do that. So now let's add that. So cipher text builder dot append, and instead of that we're gonna copy this entire thing. I'm guessing just that much into here. And I will be adding comments into my repository soon if you were wondering for some reason. If you were wondering for some strange reason, okay. And then, okay, so that's basically that line that we need here. Otherwise, it'll just enter the symbol or whatever it got there, okay. So cipher text dot append C, and it's that simple. So I got the name wrong. Of course I did. Okay, else cipher text builder dot append C. So now at the end, instead of ref is giving null, we just say cipher text builder dot toString. And now the encode function should work. So let's try it out here. So let's say sys out control tab if you're wondering. So you do sys out then control tab if you want to do things. Okay, so here let's just split our screen a second. So we'll get a new Chrome tab in. Okay. Just a second. So here we'll open a Caesar cipher thing. Decoder, right? So this, obviously I don't own it and that kind of stuff. So yeah, here let's just drag it in here and then put it to the left of the screen and that to the right and left. Okay, so now this is what we're going to use to just test our algorithm here. So we're going to encode it, we're going to enter the string, which is probably going to be the same one as here just to test it. So paste that in there. And then enter the shift which we're using here, which is 13. And now when we run this program and run this, fingers crossed it's gonna work. And as you can see, they are exactly the same. I think. Yeah, they're exactly the same. So if we just copy this into here and use the same key, because 26 minus 13 is 13, and we click decrypt, genius without education is like silver in the mine. And what's that supposed to mean? It's supposed to mean that education, because you won't be able to train your mind or something. Yeah, so that works. Now we're gonna make the decode function, which is pretty much the same, honestly. Static string, private static string decode. Okay, and we're gonna take string text and an int shift as the other one did. Okay, and here we're just gonna return the encode function, except it's going to be 26 minus the shift here. So we'll explain what that's supposed to do in a second here. So we'll say return encode text 26 minus shift, and we just copy all that. Well, not copy anything really. Okay, so now what we'll do here is we'll basically say string encoded is equal to, and we'll just set it to what this is. So copy that, paste it here, do that. Okay. Actually that's not exactly what it's supposed to do. Okay, wait, so what we're supposed to do is we're supposed to encode this comma 13. Cool. So now that's not supposed to happen. We're just supposed to print encode. Okay, so Genius is going to encode that, and it's going to give us encode. And we're also going to also have an int to shift here, so I can show you what it's supposed to do. Is equal to 21 for now. Okay, because they just love 21. Okay, to shift.
It's 9:45.
Okay, so here the to shift value is going to be a constant. Okay, and we're going to get this in to shift. Okay, and then here we're going to basically sys out this. We're going to decode this, the encoded string, okay, by the same number, and I'm going to show you no matter how I change that number, still going to give us the same output. So encode comma to shift. Okay, there's one thing we have to do before we do that, and that is actually input a failsafe in here, where basically if we give an invalid cipher number, so if it's above 26 or less than 0, then it's invalid for reasons unknown to humankind. So, well, it's not illegal as such, it's just kind of useless, so don't need that in our life. Okay. So we're just gonna add that failsafe in here. Just a second. Okay. If shift is less than 0 or shift is more than 26, I guess. No, it's either 26 or 25, but I don't think it makes a big difference. So then just system.out.println shift is invalid, and then just return null, I guess. But yeah, so the thing is, this is designed to be like a library kind of thing. It's not designed to be used as a program itself. It's designed to be used in other applications or whatever not else you're going to use it in, right? So now that failsafe has been built in and we can't get any erratic values, we're just going to test this out once. So, and you can see this is more or less the same as this, other than the fact that this isn't capitalized, but that's the thing about that thing. Yeah, it's the thing about Caesar Cipher. I mean, like, it's possible to do it like with capitals, but it'll just be a lot more time consuming, so there's no real point in it. I mean, like, you'd have to have this for lowercase letters and another string for capital letters, and there would be a lot of things to do, so there's just no real use because anyone can know things, you know. So now no matter how we change this string or this number, as long as it doesn't go over 26, we should be able to do whatever we want to do with things. So this will basically, as you can see, if you shift this by a particular value, then this will just do the inverse of that. But now here we go to the cool part. Okay, so what this feature is going to do, okay, is only going to take in a string. It's not going to input the shift. Note that this will only work for messages in the English language that have been changed by Caesar's cipher and contain a decent number of English words and are just full of names, because then it won't work. So private static string decode. So it won't work for other things, and it's probably not too accurate. It's just generally decent. So I mean, like in the test cases that I've used it, it's worked the entire time. But don't add it as an extra feature in any application that you're doing, not as a main feature. Okay, because then it's gonna disappoint your user if it fails, which isn't good. So we're just gonna do that. We're just gonna keep it returning null for now. Okay, so here we go. First, before this, we need to create a few variables, okay, that are gonna store our list of words, which is gonna be really long, but it's only gonna take about 6 MB of RAM. So unless your computer is not able to run 6 MB of RAM, in which case I don't know how the crap you're keeping Eclipse open. It's recommended to do this because it's not even that bad for your computer. Okay, cool. So now we are gonna make a few things. So first we're gonna import the java.util.arraylist. I know a lot of people do java.util.star, but I find that inefficient, and I don't like doing that. So I'm just gonna type in all of them here. There are only 3, so it doesn't even matter that much. Import java.util.scanner and import java.util.arrays. We don't actually need that, I don't think, but we might just use it if we want to print the toString of an array when it's being rather uncooperative. Okay, we do need it. So here we go. We also need to import 2 more classes. Import java. I left the space on purpose because this is a different kind of library type thingy, whatever you want to call it. Import java.util.file, not util, io.file, file not found exception. And disregarding my exceptional spelling, it's all good. So now what we're gonna do is we're gonna create a new method, which is gonna be, okay, one thing that I made a mistake on, these are supposed to be public, not private. Typing goes down the drain. So yeah, if you just wanted to do this much, you can like disconnect now if you were watching, which my sources indicate none of you were, so it doesn't even matter. Yeah. Okay. So now we can do things. So let's see now here. Scanner file. Dictionary.json. Okay, so we're gonna have an array list of strings with words in them. String words is equal to, no, it can't be final, I don't think. No, it can be final, I think. No, it can't be final. Okay. Private static, and it shouldn't be final, so remove that. So we have private static array list of words, And we have a private static file on string position, which is where we place that dictionary file. So private static file on string position. Okay, we're gonna set it to, in this case, it's just words underscore dictionary dot JSON, I believe. Otherwise, we'll have to check on it again and see about that. Right now, it seems good. Oh my god, string. Okay, cool. I think it's working now. Okay, I think it's working kind of ish now, maybe. So now we're going to make a list of all possible outcomes. So but first, before that, okay, I'll write up. Use the string. Now we're gonna have a public static void setup decoder, because we need to set up the decoder. So what this void is gonna do is just going to set up the dictionary and the words array list, and we need it. So here we're gonna have a scanner file is equal to new scanner new file position. So depending on the position of your dictionary.json file, so you can even place it on your desktop if you wanted, right? You can change the position file thingy, and we'll add it to those declaration because we're just savage like that. Okay, so now we'll know if it doesn't find the file, and if we just run the setup decoder once, hopefully it will find the file. Yeah, okay. Now we just run this. Okay, it clearly found it, so that's good, because otherwise it wouldn't have found it and we'd have had problems. So now we're gonna string builder, JSON builder is equal to new string builder. Now we're gonna do the basic file reading sequence. File.has next, then if file.has next, JSON builder dot append file.next line. Then we'll just append another thing, which is the new line thingy. Yeah, I'm making a lot of sense right now. Just gotta love that English skill, you know, /n. So it'll add a new line. Then we just add a semicolon there, and that's done. So now it's gonna read the file. Now we're gonna have to set up a string from that. So string JSON is equal to JSON builder .to string. So now I would use the JSON library, but it's probably just not worth it, so I'm not bothering. So now JSON.replace. To replace the starting brace, we have this sequence. So this is gonna just remove the starting brace and replace it with an empty string. Then we're gonna have the same thing for the end string. Okay, so we're going to do that. I'm just gonna delete that, add an empty string, and we're done here. After that, yeah, so that's pretty much all we need to replace right now. And then we have words is equal to new array list. Wait, no. Okay, a new array list. Arrays dot as list json dot split, and this is a string that you're gonna have to copy down from the video here. So the string here is semicolon space 1 comma space, then just put a semicolon at the end of that. Wait, no, this is something else. It fails me what it is. Okay, so yeah, now words has been set up and everyone is happy, so we'll just go ahead and run that once. And now what we're gonna do is we're gonna just for a test once, we're just gonna print the toString with that. So arrays.toString words.toArray. Here we go. So if we run this, what? Okay, here we go. So for some reason it printed it twice, which is kind of weird. But that's what it should be showing, so that's fine then. One thing I want to try before we move on to the next feature, just remove those double quotes because they're really annoying. Let's just see if this works. If it doesn't, that's cool. Okay, it doesn't work for some reason. Just remove that. Don't even get why it doesn't work, but it just doesn't work. It just refuses to work. Okay, but anyway, it's showing what it should be showing. So, cool. So now that we've done setting up the decoder, let's move to the actual function that we're going to be doing. Okay, so here we're going to basically say, so first what it's going to do is it's going to loop through every possible shift value. So between 0 and 25, I believe. Yes, 25. So let's have over here, let's say for int I is equal to 0, I is more than less than 26, right? Yeah, and then I plus plus colon I plus plus, and then we have here, and everything's set up for us. Great. So now what we're gonna do here is we're gonna say we're gonna decode it by that value plus the text that we got here, I believe. Yes, the text that we got here. So string decode text. Okay, so what it's gonna do is it's gonna check if there are English words in this thingy, and if there are words, then it's gonna be cool with it. So code by text. Okay, now it's gonna decode text. Oops, code recursive method. Okay, so here we're just gonna say I, so it's gonna actually have a shift value. Otherwise, we've just messed up our entire program to high heavens. So now that we've done that, we need to find the minimum number of words required for things. Okay, So what we're gonna do here is we're going to basically, one second. Okay, so then we're gonna split this thing, string text words, I guess text words will work. String array of text words is equal to decode text dot split by spaces. Okay, so hopefully our encoder's been nice enough to space out his words, because otherwise it's just gonna wreck up this algorithm and it's not gonna. So that's why I recommend don't actually do things like include as a main feature in your app or whatever. Okay, so then we're gonna say a minimum number of English words. Okay, so we're aiming for every 4 out of 7 words to be English. So we're gonna say double minimum words is equal to text words dot length divided by 1.75, and we're just gonna give a semicolon there. So this should take into account all of your names and stuff, unless it's a long paragraph about names, in which case it might mess up. But I found that this is the best value over many values that I've tested. So now, let's see. So now it's gonna basically remove. Okay, let's just assume that you've not put any punctuation for now. I mean, like, you can make a replace methods to replace all sorts of punctuation, or you can search up ways to remove punctuation, but I'm just too darn lazy. So int English words, which is the number of words that are in the dictionary, is equal to 0. Now be aware that this dictionary isn't exactly accurate, so you can get some weird results sometimes. So that's why I'm suggesting what I said. So for each string, is it a string word here? No, okay. String word in text words. Next words. For each string word in text words, if words dot contains plus, okay, so basically a word in the dictionary file with the string format will look like this. Okay, so for example, as, okay, so this is going to be the string value of as. It's actually going to have those double quotes in there. Just trust me on this one. I've already made this repo once. Okay, plus word plus then that same sequence again. So it's a backslash and then 2 double quotes. So basically this backslash is making sure that this double quote doesn't end this string. That's all it's doing. If you were wondering at any point for some reason. Okay, string length is still good, so that's good. So if words dot contains that word, so if this word is English, in other words, then we'll add 1 to the English words plus. Okay, now for each string word in text words. And now if the number of English words, I believe, is greater than the minimum required amount of words, which we just set over here, then it will be classified as an English string and it'll output it. So now let's just add that one statement. In words is greater than or equal to min words, then return the string over here, which is decode text. I'm sorry if my explanation wasn't too great or something, you weren't able to understand this too well, But go through the code a few times, type it down yourself, and you'll eventually understand. Okay, just before this, we need to close that scanner. So do that so that we don't have a resource leak. And cool. So now, if we save that, we have perfectly written code in quotes. So here we just write a result as fail. So if it fails to find any English words, sufficient amount of English words, and that'll just return fail. It can also return null, it doesn't really matter. Okay, and then what we'll do here, we'll just remove toShift. So now, if you run this, and we have a problem. What's wrong? Okay, we have a problem on line 67, which is here. Okay, so for some reason, okay, I get what's wrong. We just need to run setup decoder higher up before we actually run decode. That was a dumb mistake. Okay, so we need to run setup decoder like first thing because it's the most important thing. Now, if we just run this, wait for it, and yes, it does it. It actually works. So you saw I haven't entered a toShift value, but it figured out that there were sufficient amount of English words for it to be an English string, and it works. So yay, I guess. So now you have multiple methods and you know all of them work. So now you can just delete out this very static voids main, right? And now you can use it in any application or program you desire. Or if it didn't work, then you can just go and download my repo, I guess. So that is the finished thing of things. And yeah, I guess that's all then. So bye.